From the beautiful studio of Way Happy, this is Mr. Meyer coming at you with 2-1 Algebra 2, solving linear equations and inequalities. All right, so we're going to solve some equations real quick. Something you've been doing a long time and you've always enjoyed, so why not enjoy it a little more? So we're just going to set up some equations here, and we're going to try to go by whatever the easiest thing is to see. So as I look at this equation, this first one, they say a local phone company charges $12.95 a month. All right, that's flat fee. You're paying $12.95 no matter what, and you get 200 minutes of airtime. Then if you go over those 200 minutes, well, they're going to charge you 7 cents for each additional minute. Now, here's my daughter, Nina, and not really, her name's Jordan or Lauren, but Nina is here, and she has got a bill of $14.56. So we know she went over her 200 minutes, right? I can obviously see she went over her 200 minutes because her bill is higher than it should be. So let's figure out how much higher it is. Now, you know, math geeks love equations. So I'm going to make an equation real quick. I'm going to say the cost is $12.95 plus 7 cents a minute if you go over 200, right? So I should say like if m is greater than 200. The only reason I say that is because, I don't want you to use this equation if the minutes are only 100. And I should probably say that m should be the number of minutes over 200, right? So maybe I'd say you don't really have to do this, but it's nice to worry about where m is minutes over 200. So there you go, covering all my bases. So m is the number of minutes over 200, and that's a good equation for that. All right, let's find out what this girl paid, though. That's what they care about, right? So how many minutes did she talk? Her parents are upset. So $14.56 equals $12.95 plus the 7 cents a minute. So first thing I'm going to do is look at solving this equation. You always want to look for your variable or variables or whatever you're solving for, and decide from there. Now, the first thing I notice is that 0.07 has an m attached to it, but the other two guys don't. The 1456 and the 1295 don't. They are common terms or like terms. So let's get them together. Now, let's move one to the other side of the equal sign. So I'm just going to subtract 1295 from here. I'm going to subtract 1295 from here. And real quick, that gets me, see, that's like subtracting 13. So it's $1.56, but then 5 more. $1.61 is equal to 0.07 m. And so now I can see that she was charged $1.61 over her bill. Now I just want to know how many minutes that is. So now I'm going to also move the 0.07 over. Now, again, be careful. This isn't adding or subtracting because one has an m and one doesn't. They aren't like terms. So now I have to break this apart. I got to pull this 0.07 off of the m. Well, I have to divide it. So I have to do it to this side also. And that should tell me, what is that, about 20 minutes, 23, because it ends in 1, 23 minutes. So now I know that Nina has gone 23 minutes over, and that is why she was charged $14.56. So there you go. Little word problem for you. Not spooky, not at all. All right, what about example 2? How about if you see distribution? Would that scare you? I hope not, right? Distribution's been around for a long time. Now you have two options to solving this problem. We can distribute the 4 through. Very legal. And so I'll do it that way first. So I'm going to distribute the 4 through. I'm going to have 4m plus 48 equals negative 36. And so now the next thing I might want to do is go, I'm going to combine like terms, right? I have a 48 and a 36. They don't have m's on them, so I'm going to subtract 48 from this side. Whatever I do to one side, I do to the other. And I have 4m equals, was that 84? Negative 84. And now I'm going to break that 4 out. I'm going to divide by 4. And I'm going to get m is negative 21. Boom. M is negative 21. Finished. Done. Love it. Something I'd like to point out, though, is you could have done this a different way. You could have said, 4m plus 12 equals negative 36. You could have said, all right, I'm going to divide that 4 over because that's a constant and the 36 is a constant. Why not get them together? The 4 is multiplying, so the opposite is dividing. So I could divide by 4, and get m plus 12 equals, now that's negative 9. And then I'd be like, oh, look, I got the m almost by himself. I'm going to subtract 12 from both sides. And I get m is negative 21. Notice the exact same answer. You could have done it either way. And if you want to be a super rock star, take that m, plug it back in, because we all like to know if we got it right. We're saying m is negative 21, so we have 4 negative 21 plus 12 equals negative 36. Well, parentheses first, so 4 times negative 9. And then if I multiply that out, oh my gosh, it is negative 36. So I have now done the problem twice, and I have even checked my work, and I'm feeling pretty darn good that my answer is correct. All right, let me ask you a question, and we'll be right back after this short break. Nice work. All right. Now let's talk about what happens if you have a variable on both sides of your equation. So again, it's just combining like terms, but this time be a little more mindful that I have k's that need to be combined on the left side before I do anything. And then I have a k on the right side that still needs to be combined. And then look at all those constants floating around. Why the heck are they not also together? So therefore, we got a lot of work here to do. So I'm kind of just going to go in order. Like I'm going to figure out what this is. So 3 minus 14 was that negative 11k. And then here I have 25 minus 2 is 23. And then nothing to do over here. So that side was at least cleaned up. That made me feel all right. But now I'll finally combine terms. Now you can either move the 6 over to the 11 side because they both are k's, or you can move the 11 over to the 6 side. You pick. I'm going to move the 11 over just because a lot of people don't like it on the right side, and I want to move it to the right to make some of you uncomfortable. So there you go. I got 5k minus 12. And now, finally, I have a 23 and a 12. I'm going to add that over. Now, why am I adding? Because it was subtracted on the right side. So I'm going to do the opposite. So they cancel out on this side. And whatever I did on one side, I got to do the other. So that's 35 equals k. And lo and behold, 5k. And lo and behold, I get k is 7. And again, good choice would be to check it out. So you got 3 times 7 minus 14 times 7 plus 25 minus 2. Does that equal negative 6 times 7 minus 12? Now, that's a step you want to do if you have time, and that you want to make sure you got it right? 21, and then minus, was that 70 and 28? So that minus 98 plus 25 minus 2 equals negative 42 minus 12. So the right side I can see is negative 54. Looks a little more challenging on the left side. I see here the 21 and the 25. What is that? That's 46 minus 2 is 44. So I got to add 44 to this, which looks like negative 54. And lo and behold, they are the same. And therefore, I am good. So that one worked. All right. Look at example 4, though. Same kind of problem. And we worry about what could happen here. So again, I see some v's here and I see some v's here. So 3 minus 4 is negative v minus 9 equals, now a little distribution here, negative 5 minus v. Not bad. And then hopefully you're going, oh, now we got to combine like terms. So let's add this v over to the other side. Nice move. And you get the v's cancel like they're supposed to. But then the v's cancel on this side, and that scares a lot of people, but it shouldn't. The only thing you should do is you should go like, hey, did I do everything right? I look back, I go, yeah, I didn't do anything wrong. I'm not too worried there. And so I look at everything canceled out. Now I don't have a v to solve for. So lo and behold, this is my answer, but it doesn't make any sense. Negative 9 can't equal negative 5. That doesn't work. Those two things aren't the same. They can't be equal. So this is an example of having a problem that has no solution. And that would be your answer, because that just does not make sense. Now look at B here too. This one should be a little weird too. Distribution. I'm going to do 2x minus 12 equals, now negative 5x and 7x, that's going to be a 2x minus 12. And you might notice something already. But again, combine like terms. I'm going to, lose everything apparently. Combine like terms, I'm going to subtract 2x from both sides, and I get negative 12 equals, they canceled out, negative 12, just like before, no solution. Oh, wait, this is actually a true statement. Negative 12 does equal negative 12. So that means there's many solutions. There's so many. There's tons of answers that you could pick that would work in this problem. And so that's the difference between a many solution problem and a no solution problem. There's so many solutions on the B problem, I don't even want to think about finding them all. There's so many. There's infinitely many because you could pick any x value and it will work on both sides. It'll make the two sides equal. So that's why that's a many solution problem. The left one, problem A, nothing works. Don't even try. It's wasting your time trying to find a solution. It's just a mean trick somebody tried to play on us. All right, let me ask you one more question and we'll come back and finish this up. All right, good job hanging in there. And now let's get this last example done and we're out of here. And then we can practice some in class. So this one is solving an inequality. Now, inequalities are a little tricky because this inequality is saying everything on the left side is always bigger or equal to everything on the right side. And so that can't always be true. There's got to be some numbers that are like, nah, it doesn't work. So we're trying to figure out what numbers is that actually true for. Luckily, it's a lot like solving the equations you just did. I mean, I'm going to combine, in this case, I'm going to combine like terms. So like the constants need to be combined and the variables need to be combined. So first step, I'm going to move the 13a to the left side because many of you would probably do that. And I also kind of did it because I want a negative in this problem. So I'll have a negative 5a minus a 2 is greater than or equal to 8. Then I'll move that 2 over. I'm going to add that 2 to the other side. And I'm going to have a negative 5a is greater than or equal to 10. And now the big trick, I'm going to divide by negative 5 to get a all by himself. But the big worry here, right? Hopefully you're screaming at me right now saying, hey, flip the inequality, right? Because remember that one rule that whenever you divide or multiply by a negative number, and I just divided by a negative number, whenever you do that, that flips the inequality. So this now turns into the 5's cancel and you get a, but you get less than or equal to negative 2 because 10 over 5 is negative 2. And so on a number line, that means here's a 0, here's 1, here's 2. Oops, I need negative. Here's negative 1, here's negative 2. Everything has to be below that. So you get a filled in circle because negative 2 is a good answer and everything below that. So there's your answer. Right? That's the graphing. Here's how you would write your answer. Here's how you would graph your answer. And if you want to go a step up, a lot of us like to write it like this: negative infinity to negative 2, and we use a bracket to include the 2. Those are all your answers. So all your answers are the set negative infinity to negative 2. All right. Good job. And I'll see you tomorrow. Stay happy.